Yeah, so my name is Neal. I am the founder and CTO of Ucare.Ai. So after almost 30 years in the IT industry, mostly working in the US and then in APAC for companies like Google, Microsoft, I said, I got to start my own company. So that's Ucare.Ai. So specifically, our mission is bringing this exciting, transformative technologies to your organizations, right? So ML is very, very disruptive, very, very exciting of what you can do with it. But how do you go about it? And this is where we specifically focusing on two areas. So the first one is we focus on the predictions that you could act on. Right? And this is not just about building a business case so you could get money and fund it and get this project going and then operationalize it. This is actually looking at the impact. So I firmly believe when you have impact in your organization, the adoption will flourish. So that's step number one. We will help you to develop high-performing algorithms with high predictions in terms of accuracies so that you could actually take it and run with it. But once you have the algorithms, of course, you're going to pass it on to the technical people, and they got to manage it, deploy it, monitoring at an ongoing basis. So this is where we're also developing the tools, the modules and systems, so that it makes it easy for your technical staff to take it and run with it. So these are the two objectives that we try to achieve at Ucare.Ai. Our product and our technology is actually industry agnostic. However, given that I'm a MIT engineer, I always want to take on a bigger challenge, something hard, right? So you could really build the architecture, do it everything right for something much more complicated, and you could deploy it into something similar. So we actually move ahead very, very quickly in the most challenging and most sensitive data that you get your hands on. And also, I hope this is the vertical that will give us a lot of social impact as well. So that is the healthcare. I think we all know how private is your medical record, how sensitive it is, right? And not just at individual level. But what about at a personal level? Right? I mean, sometimes I don't tell my wife what kind of condition I got because of whatever reasons, right? So it's really at a very, very personal level and how you actually make sure you could protect that. At a government level, there are compliance that you got to go through. Anything you do in the medical space, there's a lot of compliance you got to make sure you follow through. Then on top of that, the systems, right? The legacy systems that you got to work with integrated, medical grade and all kind of things. There's a lot you got to do. So this is where we actually cut across in the healthcare space. We're working with the hospitals, working with the medical healthcare insurance companies. And of course, as the devices coming up, there are a lot more information you could actually leverage on and build on top of. And as we kind of move ahead, we'll go across in terms of insurance, the financial sectors, the securities, and other verticals. To make this all happen, this is where we'll give you a very high level of what we do architecturally. So specifically, it starts off with what we call the connectors. Connectors pointed to all the data sources in your organizations. First thing we do, anonymize it, encrypt it, and then we bring it over to our Algo platform. And Algo platform is where the magic happens in terms of we're developing the algorithms, we deploy it, we monitor it, and we iterate it. And this is where it is, if your teams want to get involved as well, you can actually use the same Algo platform. Once you have those actionable predictions, what do you do with it? Of course, you send it out through the activators to the various systems in your organization through the activators, right? And this could be a front-end app that your front desk is using. It could be a dashboard. It could be an application that you use. So this is where we actually architected accordingly to make that happen. And there's specific reason. I think you heard a lot of presenter talking about some of the challenges and some of the things and issues that you come across as well. So let me give you a very concrete example. So today, if something does happen to you, you got to get hospitalized, right? And you are going to the private hospitals. So we have worked with Parkway Pantai, and they are one of the largest private hospitals in Singapore. There are 4 of them. When you walk in, there's a system running there 24/7. It's an AI engine powered. All right? And I'll walk you through exactly what we do and how we get there. What is their problem statements? So number 1, of course, they have a historical model already in place. When you walk in, before November 15, that model was running. It will tell you how much cost is going to be, though it's not that accurate, number 1, because it's based on historical. Number 2, if something does happen during your stay in the hospitals, for example, complications, or the doctor saw something when they operate on you and want to take something out. So that added additional complication and cost reflected in your final bill as well. Lastly, this historical model is actually pretty hard to build and makes it very, very hard for them to update regularly. And what does that mean? That means the patient profile, the disease conditions that's coming through on an ongoing basis, they could not adjust it, adapt to it. So what we did was we actually use ML, build the algorithm for them, and this is at a personalized level. So as you walk in, if you have historical interaction with the hospitals, we'll leverage that information and really understanding at the individual level. And we did this in 6 weeks, okay? And of course, right off the bat, we see the improvements very, very quickly. And this is where it's a large exercise where we work across multifunctional teams that includes the IT, the front-end staff, and I'll touch on that more as well in the next slides. I think this is very common. I mean, if you have developed and deployed large IT systems, of course, you got to deal with the process, you got to deal with the people, and part of it is all change management, right? I think we heard that prior as well. So this is a pretty common exercise, and you also have to plan it out accordingly. But what is so powerful about AI and ML, machine learning? And this is where the next 2 steps are actually very, very critical. Oops. So I call monitoring and iterating. The model we built, and hopefully that's the power of the machine learning and AI, it's not static. You continue to feed it more information, it continues to learn and improve. And over time, it gets better and better. But it's very, very hungry for the data, right? So data has errors, and how do you monitor it, capture it, and how you deal with it accordingly? And then, when you have better models, how does that impact your process at an ongoing basis? So this is what I meant is, these are 2 key steps. When you start talking about bringing the transformative, disruptive technology like ML, these are 2 characteristics that you really want to maximize it. You should plan ahead accordingly. And that's what we have done as well in that sense. As a tech person, I always like to give you the demo and give you kind of look under the hood. But in this case, we'll give you a quick videos, and then you can actually see exactly what we do behind the scenes. Specifically, pay attention to what we call it the safety switch. When things are not working quite right, the models, what do we deal with it? I think some of the presenters talk about that as well. As we train the model at an ongoing basis, what do you need to do to make sure something doesn't go wrong when you're operating 24/7 in the hospitals? So literally, when you see what we're doing behind the scenes, these checkpoints are actually put in place. And as the machine learning keep going through it, you get better and better model. But at the same time, we're making sure the accuracy is there, right? The performance is there. And we're making sure it's actually deployed accordingly to your systems. And this is where I think earlier this year, we are part of the use case in the healthcare space. But specifically, let me call out a few things here. So by doing so, we continue to test the models, making sure that what we promised to our clients is there. But the model continues to improve. And again, that's the magic about ML and machine learning is it got to get better, right? I mean, if you do it once, that's it, no point. Then this is back to you keep feeding in more data. And I mentioned earlier, you have the wearable data and all those kind of things coming in. That will be part of the data streams that go into our processing and engagement. How do you make sure the data are protected? And this is very, very careful in this whole exercise of ingesting the data, and I mentioned earlier, we deal with that through the connectors. Lastly, the two key pieces, and this is where we firmly, firmly believe that human in the loop is so critical. And the fact is, the machine here are to help and augment the people. Of course, there's certain vision of automating something 100%, but the reality is, humans still thinking faster and moving faster on the non-mundane task. So this is very, very critical, is how you maximize, leverage your organization back to the people and processes that you continue to evaluate and continue to leverage the actionable items you're getting from these algorithms. So with that, I would just say, when we build a trusted AI, can you imagine the data flow that we could actually go through? And this is the power. I mean, that's why we are so aligned in terms of making sure we have the whole process, the governance in place, so that you are comfortable with the AI we're deploying in the ways that you could really leverage it upon. Of course, we love to change the world. I mean, that's what I'm here, right? I mean, after so many years. So, thank you.
Before we invite our last speaker for this series, any question from the floor? We can manage just one question. Okay, the same gentleman.
Hi again. I'm not sure why I'm the only one asking questions, mostly. Except for, yeah, that's true. Yeah, no, I'm not the only one. Okay, so my question is about accuracy, because basically from looking at the what you've basically shown, how are you basically ruling out things like unbiasedness of outcomes, for example, in terms of protected classes, lower income brackets, and things like that? Accuracy is not just a central measure. And also in terms of the data going into it, because being human-centric and having a human in the loop does not necessarily mean that your outcomes are going to be fair.
Of course, and this is where back to when we're working on the models with the data scientists, we're constantly looking at the data. And I think some of the presenter mentioned earlier, right, is you got to bring in the experts, the human intelligence into a place. Is it a persistent bias that you called it out? Or is the data is actually telling you something differently? And this is where is the engineers like myself and data scientists, and we'll keep looking at the data and come out with like, this is the best suggestion ever. Bring the human into the loop and really understanding what is that context and how we actually mitigate, and where the governance come in as well in terms of making sure we don't overstep the boundary.
One final question over there.
Hi. You mentioned earlier about dynamically changing factors such as disease aggravation and unexpected complications that may extend hospital stays. Is the machine, the AI machine, able to predict these things to estimate the bill size? I mean, the likelihood of it happening and the hospital stays extending as a result. How accurate are such predictions?
Yeah, so this is where back to it really based on how much data we're able to aggregate and process. And to share with you, I mean, right off the bat, we know if I go to a hospital, I'm old, but I'm still pretty young in the sense, I'm pretty healthy, right? You know, I get an operation in and one day I'm out. But if it's 60, 70 years old person coming in, maybe pretty healthy, the risk is slightly higher as well. So this is where it's back to earlier gentleman mentioned about a bias. Are you able to really understanding what is the data and machine are telling you, and how do you actually map it out into the real world and apply in this case. And this is where we're working very closely with the staff on the ground and making sure that we continue to review the models so that it's within the boundaries that we understand, right? And also, there's the safety switch I mentioned earlier. You always need to have a safety switch in a case where you have such a complicated systems that you want to make sure it's managed properly.